in chapter 1, we talked about inverses. And does anybody remember anything about inverses? Awesome. So this is a good review. Do we remember how to graph y equals x squared? Y equals x squared. We've got a vertex at 0, 0. We've got a point at 1, 1, 2, 4, 3, 9. Just square the numbers. Negative 1, 1, negative 2, 4, negative 3, 9. Just squaring those numbers. You know what? You will not need graph paper with the exception of this first question. It's actually just more like algebraic working out stuff today. It's just like regular paper with the exception of this one. Okay, so somebody has to remember something about inverses, just something at all. We did a whole section on it. Wasn't that long ago. It's chapter 1, the very end of chapter 1. Plus you did it in algebra 2. Caleb. We're going to switch our x's and our y's. On the graph, it is symmetric, or it reflects in the y equals x line. So if I replace my x and my y, I'll still have 0, 0. I will still have 1, 1, but now I will have 1, negative 1. I will have 4, negative 2. 9, negative 3, or 4, 2, 9, 3. So these two equations would be inverses. These two graphs would be inverses of each other. And when I talk about the word function, the original function, the y equals x squared, is a function. It passes a vertical line test. There's only one point that hits that vertical line at any place. Is the pink one, is the inverse, is that also a function? If I draw a vertical line, does it only hit once? No. So the inverse is not a function. So what we did when we were doing this chapter is we actually manipulated some of the questions so that we could make them into functions. Like when we graphed y equals x squared, we didn't graph all of y equals x squared. You guys remember? We graphed part of y equals x squared. Perhaps maybe we graphed the left side of y equals x squared. Perhaps there was a little comma that said that x is less than or equal to 0, and we really only graphed the left side. If I only graphed the left side, when I did the inverse of it, it would only be which part of my inverse? Would it be the top part or the bottom part? It would be the bottom part, right? It would just be this bottom part. And then would this now be a function? Right. It would be the inverse of the original equation. This function would be the negative square root of x. That's what the inverse would be if we had the domain restriction. So today we are doing inverse trigonometric functions. So the past 3 days we've been graphing trigonometric functions. Today we're doing their inverses. So we're looking at switching x's and y's. But if I were, so here's the sine function graphed. If you just look at this picture, if I were to take this and switch all my x's and my y's. So maybe I'll do it this way. If I were to take this and switch all my x's and my y's, Can't do it on here. If I were to take it, let me try one more thing. Okay, there we go. If I were to take it and switch all my x's and my y's, would this be a function? Would a vertical line, look, we have a vertical line, it's the y-axis. Would a vertical line hit that more than once? Yeah. Notice something else just about this, this graph here. My y values are counting by pi's, where normally it's the x's. How come the y's are counting by pi's in this inverse? Is that Nick? What'd you say? Because the x's and y's are switched. Exactly. So we switch the x's and y's on the graph as well. So everything gets switched. So because this is not a function when we switch it, we're going to manipulate the equation a little bit. And my God, I don't remember which, this was the window I was on, sorry. We're going to manipulate the equation a little bit, and we're going to say that when we talk about functions, f of x equals the inverse sine inverse function has a domain restriction. And that domain restriction starts at negative pi over 2 and ends at pi over 2. It starts at negative pi over 2 and ends at pi over 2. And we're doing that so that we do have an inverse that is a function. We put that restriction on it so that the inverse itself is actually a function. Now, you will see that we don't only write it as sine inverse x. We could write it a different way. And a lot of people prefer this second way. And people prefer the second way because sine with a negative 1 right there tends to make people think that it is equal to cosecant. Tends to make people think it's 1 over sine, which it is not, 1 over sine. So that's where things get confusing. So arc sine is the exact same thing as saying the inverse of sine. It's just giving us a different function so you don't get confused with other things in math. So you will see both ways written in the assignment, but arc sine really is just a more user-friendly one that doesn't confuse you with other stuff. Now cosecant or arc cosecant x, when we talk about functions, they are going to have the exact same restrictions as sine. It's the reciprocal. It's going to have the same restrictions. I'm a visual person. I'm going to put it on a circle, and I want to show you where negative pi over 2 to positive pi over 2 is. And I drew this picture on a different set of notes that we did recently. Because I knew this was coming up. So the domain from negative pi over 2 to positive pi over 2 would be quadrants 1 and quadrant 4. In quadrant 1, sine is positive. In quadrant 4, sine is negative. Or cosecant, same thing. So the same basic concept happens with cosine because cosine has a very similar graph to sine. So we did the inverse, it's not going to work. We would have to trim it down so that our inverse is a function and the domain restrictions that we're going to use for cosine go from 0 to pi. So from 0 to pi are going to be the domain restrictions that we use for cosine, or cosine inverse, and remember it can also be written as, as arc cosine of x. Same thing with secant. Secant has the same restrictions as cosine. And in the first quadrant, cosine is positive. In the third quadrant, cosine is negative. So we get all of the positives and negatives for cosine or secant that way. And then finally, tangent and cotangent. I don't have a picture of these up here. We should know what tangent and cotangent look like. But for these, tangent or arctangent has a domain restriction of negative pi over 2 to positive pi over 2. So I'm going to just draw that picture. But cotangent or arccotangent has a restriction of 0 to pi. Now, when you guys graphed tangent and cotangent in your assignment and in your review, those of you that did it, the restrictions, negative pi over 2 to pi over 2 and 0 to pi, that's what we used for our key points for tangent in those tables. So those should be somewhat familiar because we just did a whole section on them. And another thing is that sine and tangent are exactly the same. Cosine and cotangent are exactly the same. Couple ways you could remember that. For me, I think about tangent being y over x, and I think about cotangent being x over y. And then I also think about sine being y. And I think about cosine being the x. So since y is on top, tangent and sine have the same restrictions. Because cotangent's on top, cosine and cotangent have the same restrictions. If that helps at all. Maybe cotangent and cosine have the same restrictions because they're both cos. But you need to remember who has what restrictions. So here's 3 examples. These are the graphs of the inverse functions, which we are not going to do. We're not going to do the graphing, but just to see what they look like, you'll see that arcsine just goes from negative pi over 2 to pi over 2 in the range, and it stops. It doesn't go on forever. And then arccosine goes from 0 to pi. And it doesn't go on forever. But what about the domain for these? So the lowest and highest number that they can possibly go to is -1. So if I ever ask you something like this, arc sine 5, that is saying when x is 5, what is the y? Look at our picture. When x is 5, look at arc sign, which is the first one. Here you go. Look at arc sign. When x is 5, what is y? Have I stumped you? Or we're just being quiet? Anthony, do you know? No? Mark? Kira? Why don't you guys know the answer? Nick? Nick? Don't know. John? Why not? Just look at the picture and tell me when x is 5. We're looking at arc sign. Tell me when x is 5 what y is. Lydia? No? It's not pi over 2. But thanks for taking a guess. Nairi? It can't go to 5, so it's undefined, yeah. It's exactly right. Good job, Nairi. But, like, the graph doesn't go to 5. So, you won't have a value. That's why you couldn't answer me. All right, same thing with cosine, but tangent is different. Tangent, it doesn't show it right now, so we're going to add it in there. Tangent doesn't stop. It does keep going, and it gets closer and closer and closer to these asymptotes. So it does keep going forever and ever and ever. But tangent does have a limit when it comes to the range. Okay. All right, so this is what you're going to be doing for your assignment. Find the exact value without a calculator. So these, it's not set up exactly like this, but this is basically saying we've got our function, and I'm plugging in 1/2. Wait, let me actually not do the 1/2 part yet. We've got our function of x, which equals the inverse sine of x. This is our function. So basically we are doing, if I plug in 1/2, what will I get out? That's what's happening here. Okay? It just doesn't have the f of x. It's just telling you to find this answer. So what we're going to do is, well, what I do is I start by saying sine has a restriction, and it can only go from negative pi over 2 to pi over 2. I should know by heart, by memory, where sine is equal to 1/2. What angle? 30 degrees. Okay, these are all going to be radians, so it's not going to be 30. Well, what's it going to be instead? Pi over 6. And because it is positive, it is a pi over 6 in the first quadrant, so my answer is pi over 6. Cosine has a domain restriction from 0 to pi. I guess it's a range restriction, but because it's inverse. It has a restriction from 0 to pi. This is a negative number. In the first quadrant, cosine's positive. In the second quadrant, it's negative. This has to be in the negative quadrant. It's negative radical 3 over 2. So I take from my memory, what angle does cosine have radical 3 over 2? It's 30. Well, that would be the reference angle, yeah. Which is what radian? Pi over 6. So is the answer pi over 6? No. That's our reference angle. Pi over 6 is right here. What is the actual angle? 5 pi over 6. Tangent. Negative 1. So tangent has the restrictions from negative pi over 2 to positive pi over 2. This is a negative number. It's got to be in the fourth quadrant because everything's positive in the first quadrant. So I need to know what reference angle gives tangent a 1 or a negative 1. So I don't think I heard this, but 45 degrees, which is pi over 4 is what I heard. So is my answer pi over 4? No, because pi over 4 does not put me in the fourth quadrant. So what's my answer? It is going to be negative pi over 4. Why is it not 7 pi over 4? Why is it not 7 pi over 4? Lena, do you know? Because the domain restrictions say has to go from negative pi over 2 to pi over 2. There's no 7 pi over 4 in that. It's coterminal with negative pi over 4. 7 pi over 4 is. But we have to put the answer that is in between those numbers that we're given. Okay, secant is the same as cosine. So we're going to use the restrictions that go from 0 to pi. This is a positive, so it'll be first quadrant. Anytime I see a square root 2, I'm thinking square root of 2, I'm thinking what angle? 45, so pi over 4. Is the answer pi over 4? Is the answer pi over 4? Sarah? Nold? Yes, it is. Next section, exact same questions, change the way it looks. Now it says arc cosine, which means inverse cosine. They mean the same thing, just arc cosine is less confusing. So arc cosine, I need the cosine picture. My cosine picture is 0 to pi. This is a negative. So we're talking second quadrant. But then I have to know, where is cosine a 1? At the pi exactly. And that, well, that's where it's negative 1. Positive 1 would be at 0. Cosecant is the same as sine. Negative pi over 2 to pi over 2. This is positive. So, yeah, I might want to think about arc cosecant being 1/2. Nope, just kidding, not cosecant. Sorry, I meant arc sine being 1/2. Because that would mean the arc cosecant is 2. What's my answer? 30 degrees is not my answer, but I can think 30 degrees. What's my answer? 5 or 6? I'm going to stop talking for a moment. I want you to try C and D. C and D. Okay, arc cotangent. Daniela, what is the restriction for arc cotangent? 0 to pi. And this is negative, so it'll be in the second quadrant. And then we need to know where tangent is arccotangent is radical 3, which would be the same thing as arctan of negative radical 3 over 3, if that helps you at all. Sarah Penny, do you know the reference angle or the answer or any of it? Any of the above? Pi over what? Pi over 6 is correct, yep. So that's not my answer, though. If we're going to put it in this quadrant, John, what would the answer be? 5 pi over 6. Good. Okay, and then we've got arcsine, and for arcsine we use negative pi over 2 to pi over 2. And this is negative, so it'll be in the fourth quadrant. Mark, can you help me out? Did you get a reference angle? Did you get an answer? So pi over 6 is not correct, because sine at pi over 6 is a half. So sine at something else is going to be radical 3 over 2. So what other one could it be? $60 degrees, right? It's going to be 60, which is pi over 3. Is that my answer? Anybody, is that my answer? No. Connor, what's my answer? Yep. Very good. Negative pi over 3. Okay. It's not too bad. So let's make it harder. Now we're going to do compositions of functions. And we've done things like this in math before. You're going to do the inside first. So completely ignore that sine inverse. Just right now it doesn't exist. I am going to erase it in a moment, but right now it's not there. I'm going to erase that in a moment. It's not right there. It's not there right now, though. All I'm asking you to do is tell me the cosine of pi. That's all I'm asking you to do. What is the cosine of pi? So here's pi. Yes, people are answering the correct answer. Oh, shoot. Yelling out the correct answer, yes. At pi, we need negative 1, 0. Cosine is the x, so that is negative 1. I'm going to bring down those parentheses, and now cosine of pi never existed. Ever did it ever exist? You never saw it. It's not there. What's there, though, is sine inverse of negative 1. So sine inverse at negative 1 is going to be somewhere between negative pi over 2 to positive pi over 2. It's negative, so it's got to be the fourth quadrant. Chris, where is sine negative 1? No. No, Chris can do it. I mean, he had time to plan his phone, so he definitely has time to figure this out. You remember right above it we found, I'm going to have to remove this. Remember right above it we were asked what's the cosine at pi was, and I got the answer of negative 1. And now I'm asked for where is the sine negative 1. It's not pi, but it's kind of similar. Okay, sine is what over what, Chris?
Minus y over r.
Okay. For it to equal 1, what do I have to know about y and r? Yes, but for it to equal 1, what do I have to know about y and r? Say it what?
They both have to be like the same number.
They have to be the same number. So where around this circle can y and the radius of the circle be the same number?
Be on the y-axis.
Mm-hmm. So what's my answer?
Pi over 2.
All the way up here?
Negative pi.
Negative pi over 2 to make it negative. Put your phone away. All right, the next one, same concept. I am going to completely ignore arc cosine. It doesn't exist right now. It's not there. You never saw it. And I'm just going to look at tangent at 3 pi over 4. So I'm going to go find 3 pi over 4. There it is. And I'm going to find the tangent at that angle, 3 pi over 4. That's a 45 reference. So what's the answer for tangent 3 pi over 4? Anthony?
Negative 1.
-1. So I'm going to bring down those parentheses, and I'm going to move my little scrabble. Oops, I didn't move it. I scribbled more. And now I'm not at all looking at what's inside the parenthesis. I'm only looking at arc cosine at -1. So I have a new picture, and my picture is going to go from 0 to pi because it's cosine. And I need to know where cosine is -1. Caitlin. I need to know where cosine is -1 at pi. So that is my final answer. So the next question, we're looking at cosine inverse, negative radical 3 over 2. So this is the inverse. If it's the inverse, I have to use the restriction. If it's negative, it's going to be in the second quadrant. I feel like we already answered this question earlier in the notes. Where is cosine negative radical 3 over 2? Bell. Five pi over 6. So that replaces cosine inverse negative radical 3 over 2. And then I'm not going to look at that anymore. So now I'm looking at the tangent at 5 pi over 6. This is just the old kind of questions. This is not new now. Tangent at 5 pi over 6, I go to 5 pi over 6, and I'm going to find the tangent at that angle. 5 pi over 6 is a 30-degree reference. It's in the second quadrant. What's the tangent at 5 pi over 6? Caroline. Okay. All right, the next one. Cosecant inverse -2. So since it's the inverse, we are going to start with the restrictions. And cosecant, if you don't want to look at it being cosecant inverse, you could look at it as being sine inverse. You just have to flip this number, -1/2. So it's negative fourth quadrant. When's sine 1/2? Pi over 6. So is pi over 6 the answer? It would be negative pi over 6. That's going to be written in this parenthesis here. Then I'm going to bring down the sine. So now I'm going to do sine at negative pi over 6. So now I'm going to do sine at negative pi over 6. Am I called on everybody? Mark. Negative a half. That's the answer. Good job. So these are just two problems in one. That's really what they are. You're just taking the answer from the first one to make the second question. How about the next one? So we're starting with just find the sine at negative 3 pi over 4. We're finding the sine at negative 3 pi over 4. Daniela, do you have that answer? So it's a pi over 4. Tells us it's a 45. What's the sine of 45? I heard part of what you said. Is she saying over 3?
No, radical 2 over 2.
You're saying over 2? I just kidding. Because I can hear the radical 2 and then it gets really quiet. Yeah, radical 2 over 2 is my answer, radical 2 over 2 for sine at negative 3 pi over 4. Is that my answer? Or am I missing something? Negative, right, because of the quadrant we're in. Okay, so then I'm just going to bring down arcsine. So arcsine, negative radical 2 over 2. Bless you. Nick? Arcsine, negative radical 2 over 2. Okay, negative pi over 4 is correct. Does that make sense that if we have sine of negative 3 pi over 4 and then we do arcsine, that we don't just get negative 3 pi over 4? Like, don't we normally just get the answer that's there when we cancel something out? Yeah. But with these, we're going to have these domain restrictions. So for the second part, which I didn't write, when we do arcsine, you've got to only go from negative pi over 2 to pi over 2. And so that would be negative pi over 4 instead of being in the third quadrant. All right, so does that work for secant, inverse, and then secant? Can we just cancel those out, or is it going to be a different answer? So secant inverse is where we're starting. So we're going to go from 0 to pi. It's negative. So it's the second quadrant. I need to know the angle. The angle has to be between 0 and pi. If I don't have my secants memorized, what could I change it into? Cosine. I could change it into cosine of negative radical 3 over 2 if I don't have my secant memorized. So now it really should be obvious what it is. It should be obvious. What, Nick?
Oh, I was just going to say, could you just get the answer? Because if the inverse of the thing... and then-
Well, that's what I was saying before with example 5, but did it work?
Well,
It didn't work with example 5. So to answer your question, sometimes it works and sometimes it doesn't. You could figure out when it works and when it doesn't. By doing enough of these, you'll figure it out. But like, I wouldn't guarantee it working every time until you understand why it's working and why it doesn't. Caitlin?
So on number 5, how did you get the negative radical 2 over 2? Like, why is it negative?
Because our domain restriction is putting us from negative pi over 2 to pi over 2. And this is a negative number. So it's got to be in the fourth quadrant.
So why is it negative?
Because to start at 0 and to go down will be negative. If I went all the way around, I would get 7 pi over 4, but that's not from negative pi over 2 to pi over 2. What?
I said because you're going clockwise, right?
Right, because I'm going the other way. That's why it's negative. I'll finish example 6 in a second, but I do want to show you guys, just with that example that we were just talking about, you don't have to take this out. You can just look. I'm putting this in degree mode also because if you guys know, you probably don't know what pi over 4 is as a decimal. So I'll just look at degrees. You guys know what pi over 4 is as a degree, right? Right. So if I use my calculator and I do arc sine negative radical 2 over 2 on my calculator, which is sine inverse radical 2 over 2. Oh, I forget where square root is. Oops, forgot something. One more try. If I do sine at negative radical 2 over 2, it's giving me negative 45 degrees. It's telling me negative pi over 4. This is when your calculator gives you answers. Remember that one section that we did that you had, you got into positive by adding 360 onto it? Remember that one section where we had like 2 angles? And for this one, we got negative 45 degrees, but you couldn't use negative 45 because I said it had to go between 0 and 360. Do you guys remember this assignment we did? And we had to like add 360 onto that to make it this one here. Well, your calculator will always give you the inverse, the arc sine answer. It's going to give you that negative 45 degree answer. So that's why it's giving us that answer, because the calculator listens to the domain restrictions. If the directions are to find something else, then you have to manipulate it. So going back to question 6, wait, did I answer your question?
No, but I figured it out.
Oh, okay. Going back to question 6, if I am finding where cosine is negative radical 3 over 2, that answer is 5 pi over 6, which was somewhere earlier in our notes. And now I have to find the secant at that exact same theta, which is 5 pi over 6. And secant of that theta is the same as the original negative 2 radical 3 over 3. So sometimes these will undo each other, but sometimes they won't. It does not have to do with the word arc versus the negative 1. It has to do with where the angles are. Yes? Say that again. Right, and that's why. That's why it won't work. And that's what I'm saying, like, if you do it enough, you'll figure it out. But yeah, that isn't an answer. That isn't within that restriction. That's why it can't undo itself. Okay. Now, these also say find the exact values, which means we're not going to use our calculator for these. We're going to figure it out a different way. So we're going to start with sine inverse 3/5. I can scroll back up. Sine inverse 3/5. We're going to start with sine inverse 3/5. So I have to find out where sine is 3/5. I am restricted to negative pi over 2 to pi over 2. I'm restricted. It's positive 3/5, so I know it's the first quadrant. Three-fifths is not one of our special values. It's not like radical 3 over 2 or 1/2. So we're going to do it a different way. I don't actually have to find the angle. I don't actually need to know the angle. I just have to know where the angle is. So in my picture, this is where the angle is. That's the theta. That is sine inverse 3/5. That's my theta. So my next question is, what is cosine at that same theta? So sine inverse of 3/5 is this particular theta right here. Now I can make it more obvious that that is the cosine, the sine, because I know that sine is y over r. So when I label the sides of my triangle with my y value and my r value, I can now find the cosine. Well, almost now. Almost now find the cosine. Because what's cosine? Cosine is what over what? Cosine is what over what? X over r, which is something over 5. So what's the x value? 4. 3, 4, 5. Yay. Oops, that's not it. 4, 5. So I didn't even need my calculator. I didn't actually have to find the angle. Question 8. We've got the tangent of the inverse cosine, negative 5/7. Let's start with inverse cosine. This is a negative number. Cosine goes from 0 to pi. This is a negative number, so we will be in the second quadrant. Cosine is x over r. You guys just told me that. So out of x and r, we've got a 5 and a 7, but which one's negative? The 5. Why? R can't be negative. R can't be negative. It's a radius. But the direction at which we go for the x value can be negative. Now we have to find the tangent. And the tangent, so here's our theta. The tangent is y over x. So I need my y value. And then we'll put it over our x, which is negative 5. Now I'll put it in a moment. So how am I going to find my x value? My y value. How am I going to find y? Nick? Pythagorean theorem, because this is not a triple, so we're going to do 5 squared plus y squared equals 7 squared. So I've got 25 plus y squared equals 49. I'm going to subtract 25. And y squared equals 24. Square root. When I square root 24, it can break down to square root 4 and square root 6. So I get 2 square root 6. That is my y. And then finally, y over x. So we're going to have negative 2 square root 6 over 5. Somebody had said this earlier. Why did I just pull that negative out and not write it in the denominator? Well, but it's not r right now. Because negative, right, when we simplify it, we don't leave a denominator that's negative. Right. Yes, Caitlin?
How come you left the negative off of the side when you did the...
Very good question. Because Pythagorean theorem is for a triangle. And when I talk about lengths of the sides of the triangle, how long is this side? 5, and this side is 7. Now, had I put it in and squared it, it should still be positive 25. So some people will leave it in. But the reason why I didn't leave it in is because I've had people turn in quizzes and tests to me that get it wrong because they put a negative 25 in here. When you square a negative number, it becomes positive. When you square a negative number, it becomes positive. So that's one reason why I purposely left the negative off, because people keep messing up on their, it was on that last test when I was grading stuff. People kept messing up on their Pythagorean theorem because they left the negative. And they told me negative 5 squared was negative 25, which it is not. So, thanks for asking. All right, last one. Let's see if you guys can try it without me. I'll go over it, of course, but see if you can get it without me. See what questions you have.
You know what? Refresh your module if you haven't, because I've switched the worksheet. But I don't know when you had your module open. It should be worksheet 1 and worksheet 3. I originally had 1 and 2, but I switched it. Get it? If you guys got it, you're more than welcome to open up the worksheet, start working on it, but I'm just walking around and I'll go over it together on the video too. Okay? Nice. Oh my gosh, I really can't see. Oh yeah, I see it. Well, I see radius, where's the actual answer? Oh, okay, I thought, I'm so sorry. I thought you said you have it. Go 4, 1. Just like you're writing your word there. And that's going to be the triangle.
All right, I walked around. A lot of you had the picture drawn. And you said, well, cotangent is positive. It goes from 0 to pi, it's positive, so we're going to be in the first quadrant. Cotangent is also, cotangent theta is x over y. So my x over my y is going to be 4 over 1. So starting at 0, I go 4, and then I go up 1, and that's how I make my triangle. And that's how I find out where my theta is. Now that's super messy, I want to fix it. So I'm going 4, 1, and then come back to 0, 0. That makes my theta. If you put the triangle in the wrong place, you're probably going to get it wrong. We do our Pythagorean theorem. And I get that r is square root 17. Then we have to find the cosecant of theta, and the cosecant is the reciprocal of sine. So sine is normally y over r. This is going to be r over y. So square root is 17 over 1, which is just square root 17. For your assignment, you do have 2 worksheets. There are actually 3 for this section, and in the past we have done all 3. We'll see if we need to do all 3. It's going to be up to you guys if you're doing good and practicing it, or if you're just copying down answer keys. Because you aren't going to learn it if you copy down answer keys. For this assignment, where am I at? There's one thing I want to show you on one of the worksheets, so I'll open them up real fast. And so the first worksheet, just a bunch of what we just did. And some of these are not special. The majority of them are special. You have to have this stuff memorized so that you don't spend hours doing this and that you do actually do your assignment. And then that worksheet, I already have an upload for it, and it's one of those quizzes where you'll type in answers and check them. So if you don't want to type in every single thing every time, you can type in one answer at a time if you want and hit check. I've given you like 40 tries, and there's only 35 questions, 36 questions, something like that. But I've given you 40 tries. So you literally could check every single question and then type them all in at the end if you need to. You don't have to type them all in every single time. It's a waste of time. Okay, and then the second worksheet, at the very end of it, this section here, this 203 to 207, you will notice in the directions, it says 0 to 2 pi. So this down here is review of what we did before and what we had on our last test, because this stuff will come back in Chapter 5. So it is important that we did not forget it from our last test. So 203 to 207, you're doing the two solutions, the way we did it prior to this section. But that's just 203 to 207. There aren't 207 questions on this worksheet, by the way. This is where I snipped a different worksheet and put it on here. Like the last number before that's 106, and there's, again, not 106 questions either. Okay. 57, 40 to 57, so skip some of them. All right, so you guys have an option. You have like 40 minutes till lunch. Your option is, we really need to get on our roller coaster project. You guys can do this on your own time. Or your option is, I don't get this at all. I need to try this for a few minutes before I work on my roller coaster project. But this is some time to work on your roller coaster project if you need it. And if you haven't settled on the actual final graphs yet, we need to get that done because you have to make a presentation too. Yes, dear.
What are we doing on Friday?
On Friday, we'll be doing a